What is WaterJet Corporation? Our company was founded in 1991. We are in Italy. We are placed nearby Monza. We are one of the first manufacturers in, as far as the starting point is concerned, in Europe of waterjet cutting machines. And we just do waterjet cutting. We don't know other technologies, so our limit is that we just can make waterjet cutting machine. But this is allowing us to make continuous developments into this application. This is helping us to be nearby the customer, nearby the needs of the customer. So we are used, you know, Italy is famous for fashion and for suits, for dresses, and we are used that to say that we can tailor a machine on the needs of the customer. And this is very important because in waterjet applications, many times these machines are used for very specific applications where the customer needs the manufacturer to be with him to help him developing the machine he needs. We have some branches around the world, so we have a branch in US, we have a branch down in Brazil, we have 2 branches in the Middle East, and well, we are trying to be present all over the world. Our range of machines, we have 4 family of machines, 2 with cantilever design, that means flying bridge, and 2 with gantry designs, that means complete bridge. The flying bridge model are mainly used in the stone industry because their accuracy on the prima is 0.1 millimeter, on the practica is 0.08. Then we go on gantry design that is mainly used in fabricating and in machining industry, with the model Classica, which has an accuracy of 0.08 millimeter, and with Suprema, which has an accuracy of 0.05 millimeters. So even if we are talking about cutting tables, the accuracy of these machines is something that allows you cutting materials with very high precision and with small finishing, machining on the pieces if these have to be finished. You can use it in many applications, so it can be a 3-axis cutting, it can be a 4-axis cutting, it can be a 5-axis cutting, accurate cutting, stainless steel, you can cut gears, you can have this optimization of cutting using nesting, you can replace the punching on aluminum, you can cut brass, which is not easy to cut with other hot cutting technologies like plasma or like laser. You can cut coating metals because it is a cold cut, so what is coating the metal will not be burnt by the cutting technology. You can cut 5-axis with double bevel cutting. You can cut 5-axis in double shapes, 5-axis. And what is the big advantage of waterjet is that you have practically no limit in thickness that you cut. When you cut with laser, you know that you can cut up to a certain thickness. When you cut with plasma, it's the same. You can cut bigger thicknesses, but the melting part will be bigger. When we cut with oxygen cut, again, you melt the material. So you have a big part that will be melted when the thickness will go up. And the accuracy of cutting will be reduced when you cut with hot technologies. This is what can be done with waterjet. So you see that cuts are very clear, very clean, and you go with the 6,000 bar pump, you can reach a thickness of cutting that is over 300 millimeters. We have cut here as an example a titanium bar, which is a 200 millimeter thickness. Titanium is a strange metal, and when you try to cut it with plasma or with laser, again you have problems, especially if you are on high thicknesses. Still, you see here we can go up to 300 millimeter. It can be a first cut. This is extreme cut, so it will not be a real cut, precise cut, you can see it by the picture. It's just a separation cut. But there is no other technology, unless we think about mechanical technology, that can cut this kind of thickness. Doesn't matter if it is precise or not, but you cannot do it with laser, you cannot do it with plasma, you cannot do it with, I don't know if with OxyCut you can do it, but I mean, this kind of thickness can only be made by mechanical cutting. Steel, 400 millimeter. Stone, we go up to 350 millimeter thickness in stone. You can cut multi-layers, stacking the different sheet metals one over the other one. Floors, inlays. So you can also think about artistic cutting. Vanity tops. So here we are in the stone, which is a little bit far away from the metal, but it is the big advantage of waterjet cutting. When you cut with waterjet, you really can cut any kind of material. Pure 3D. You can go to microjet, so with some special appliances you can even, waterjet cutting is used in the watch industry, for example, in many part of the watches are pre-cut with using waterjet technology. You can cut carpets, you can cut anything. You can cut, what is also very important is that waterjet cutting technology is used a lot in aerospace. Why? Simply because you can cut composite materials without having any delamination problem. And in addition to it, you can cut, the big advantage in aerospace is that aerospace industry is asking to have no physical change in the metal that is cut. They want the metal to stay with its normal structure. And the cold cutting is helping a lot to keep this without having to grind after cutting the part to take away the part that was overheating. Glass, optical glasses, crystal. You can even engrave on some parts. On fabricating, if you cut metal sheets to be welded, for example, keep in mind that again it is a cold cut, so you don't need to grind the hardened part of the cut, but you just need to cut and then to weld together. So even in the working procedure of a metal shop, having a waterjet cutting machine, beside granting you any kind of thickness to be cut, beside granting you high accuracy, doesn't require middle additional works on the metal. Our technologies, cutting technologies, we have a standard 3-axis 2D cutting. We have 4-axis dynamic cutting. What is it? When we cut with waterjet, we make an abrasion cut. So there will be a taper in the cut. A taper that is from up to down about 0.1 millimeter on 20 millimeter thickness. With the 4th axis, what do? We go, we make a counter angle in order to reduce this taper, and we make a straight cut. So we compensate what the waterjet cutting will naturally do by a counter corner that will grant a perfect straight cut on the metal sheet. 5-axis, 2D, 3D, which means we can cut bevel, but we can cut also on 3D shapes. We have then a 5-axis system that is RTCP, so it means we go down to plus minus 90 degrees when cutting. And then we have a 5-axis 2D cutting that is specific for cutting plates on bevel. We also have added a lathe to the tank, so this means we can cut pipes without any problem. The only thing is that when we cut pipes with waterjet technology, we have to put inside the pipe a sacrificial part to interrupt the waterjet when it is coming out from the part in order it not to touch the other side of the pipe. There is a limit in waterjet technology. You control when the water is going through, but you don't control it when it's coming out. So in order not to have signs on the other part of the pipe, we have to interrupt the water jet before it touches the other side. Well, Prima, it's a machine with an integrated cantilever design, so one piece only, plus the pump, plus the CN units. Prima, the accuracies, as you can see, mechanical accuracy here is 0.1 millimeter. Repeatability is 0.075 millimeter. Ball bar at 300 millimeter diameter is 0.1 millimeter. So this is an entry-level machine. This is a machine that is normally used in fabricating and in other industries like stone or glass, because 0.1 millimeter is already a good accuracy. Practica is another flying brig machine with a separate tank from all the transmission system. This is the steel bridge where the transmission system is built. Ball screw transmission, so very high accurate transmission system. High protection, so everything is protected, double protection in order not to have any humidity, water or abrasive going in touch with the part. The backside of the cantilever system with the integrated control cabinet, which makes again the installation very simple, and how the machine is. This system is interesting because we have developed, as WaterJet Corporation, we have developed a double tank system that makes the bridge turn. Why? Because when you cut with WaterJet, in some applications there is a long loading and unloading time. And in this time, if you have only one tank, you cannot go on cutting. In this case, with this, which is patented by us, with this system, you can work on one tank while the other tank is being loaded and unloaded. This is the way the revolving device moves. So it will be lifted, moved, and fixed again. This means that you anyway have the accuracy granted. This is the way the bridge is made, and this is a double tank machine. As I explained you, while the machine is working on one side, you have the other side that is completely free for the operators to work on the tank. Well, as I was telling you, we only do water jet cutting machines. So I put some examples here, and by that system that we have seen before, which is named Practica, we have developed different modular systems that allows the customer to have the machine developed on his needs, on his demands. Classica is the gantry system machine. Integrated tank with the transmission system. Everything in one part only. Well, here you can see that there are many applications, so that you have in this case a possibility to have a machine with two cutting heads instead of only one. Suprema. Suprema is the top of the range. This machine is separate tank, so everything is, all the transmission is put separate from the tank on a frame with I-beam construction. This is the way we assembled the ball screw systems. Internal wiring, protected, everything with double bellow protection. And these are the accuracy of this kind of machine. 0.05 accuracy, 0.025 repeatability, and ball bar 0.05. This is, I was explaining you before, the fourth axis, the intelligent taper control system, which is showing you how it works here. So you have 1 or 2 degrees mechanical inclination in order to get, to compensate the conicity of the jet. This is what you get as compensation on 20 millimeter thickness, 0.1 millimeter if you use a normal 3-axis cutting head. You reduce it to 0.025 millimeter using the taper compensation. So it's not perfectly straight, but it is within good tolerances. 5-axis, 3D technology. This is our 5-axis cutting head. What is the advantage of this 5-axis cutting head is that it has a swivel systems that allows it to turn infinite without stopping. In other machines, once you reach 700 degrees, for example, you have to return to zero position. But when you cut complex parts, this rotation is not enough, so you have to stop it, go back to zero position and start again. And this means that you will have a sign on the part you cut, because when you cut with WaterJet, due to the accuracies you have and due to the way it will cut, whenever you interrupt the cutting and you start it again on the same point, you will have a sign on the part. This is the way it works. You see it physically, how it is, how it turns. So you have swivel systems that allow you having air, electricity, abrasive and everything going through the swivel system. This is the head, how it looks like. What I was explaining you, the sacrificial part here, in order to interrupt the jet when it goes through the hole that has been cut. This is again very important. I mean, when you cut pipes for high pressure plants, for example, here you can already cut bevel and they are ready to be welded. There is no grinding operation to be made on the pipes. Some example of customized machines. We go up to 12 meter long, 3 meter 35 depth. We have a combined technology, so logically there are cases and occasions where when WaterJet cutting, which is slower than plasma cutting but more precise, in some occasions you have parts that have combined cutting to be done. Some cuts have to be precise, some other have to be fast. In this case we can combine the two technologies on one machine only. Triple technology, so mechanical, plasma and WaterJet combined together. Double heads. The big advantage of WaterJet Corporation is that whatever the customer needs to cut, we can sit down with him, study his needs and develop a machine specially for him. As you will understand, the main thing on WaterJet cutting are the pumps. WaterJet Corporation is using Kmt Pumps that are coming from USA. This Kmt is the main manufacturer of high pressure pumps in the world. Our pumps are intensifier pumps. So what does it mean? It means that we have only one piston that will work as intensifier of the pressure, which compared to other manufacturers of high pressure pumps that are using the 3-piston system, so the direct driven system, we have the advantage that the maintenance of the pump is very small, very low, and it doesn't require a lot. This is how the WaterJet intensifier works. These are the components that are required to be replaced. Maintenance on the pumps is very important because we are working with so high pressure, so there are parts that have to be replaced every number of hours they are working. This is the mixing chamber where there is the water going through with a diamond calibrating the dimension of the jet, and then from there we bring down the abrasive and we go to cut. 6,000 bar pumps. These are the highest pressure at the moment we can have. I know there are some researchers working on higher pressures, but the problem is when we go over 6,500 bars, we start having a solidification of water because of too high pressure going through the pumps. I will just show you what is the difference between using a 4,000 bar and the 6,000 bar technology. It increases the cutting power density. It allows you to cut material with pure water. I mean, you can cut aluminium with 6 millimeters thickness using only water, and titanium with 3 millimeter thickness only using water. When you cut with WaterJet, as I said, it's an abrasion cut, so you will have an upper part that will be perfect, and then going down, you will have a part of the cut that will be with grooves, because water is losing the pressure while it's going through. And this is, with the 6000 bar, you reduce it a lot. Just an example here, all our machines are CN controlled, so everything is, again, we treat it, it's not just a cutting table with X, Y, Z, but there is an interpolation using a CN unit, not just connected PC to the machine, but a real CN unit as it is on tool machines. This is our quality control, so all is calibrated into the company. We use Renishaw, we use all the highest ball bar, we use all the highest technologies to calibrate the machine. This is the ball bar, which is showing the accuracy of the cut in the different positions. This is the benchmark. The finishing quality control, so we control the roughness of the cutting and everything. Well, this is all. This is all for the presentation. If you have questions and I am able to answer, I'm here.
Thank you, Mr. Ivo.